All right, hello and welcome. If you're here revising for your GCSE computer science exam, then you've come to the right place. We're about to do a super focused run-through of memory and storage, and we're going to use the official OCR J277 specification as our guide so you know you're getting exactly what you need.
So let's start with a classic question, right? RAM versus ROM. It's one of those things that seems simple, but it's so easy to get mixed up in an exam. But don't you worry. In the next few minutes, we're going to clear all that up for good.
So here's our roadmap for this explainer. First, we'll hit primary storage. Think of it as the computer's messy workbench. Then, we'll tidy things up in secondary storage, its long-term library. After that, we're going to get into the nitty-gritty of units and calculations and talk about why binary is so important. We'll also look at compression, and finally, we'll wrap it all up with the key takeaways you absolutely need for that exam. Let's dive in.
Okay, first stop, primary storage. This is the computer's short-term memory, the stuff it's working with right this second. And for your revision, this is all covered under Spec Point 1.2.1.
Now this is the big one, RAM versus ROM. If you remember one thing, remember this. RAM is volatile. That's the key word. When you turn the power off, poof, everything in it is gone. It's the temporary holding area for your operating system and whatever programs you're running. ROM, on the other hand, is non-volatile. The data stays put. It holds the really essential stuff, like the instructions to start the computer up, the bootstrap loader. And you can't change it, that's why it's read-only.
So what happens when you've got like 50 Chrome tabs open and your computer starts to slow down? Well, that's your RAM filling up. This is where virtual memory jumps in to save the day. Your computer basically ropes off a part of your hard drive and pretends it's extra RAM. It then swaps data back and forth. Now, it's way slower than real RAM, but hey, it's a clever trick to stop your whole system from crashing.
All right, let's move on to secondary storage. So if primary storage is the computer's workbench, this is the massive permanent library where everything is stored safely for the long term, even with the power off. This is all about Spec Point 1.2.2.
This table is pretty much your cheat sheet for the three types of secondary storage. You've got to know how they stack up against each other. So you have optical, like a CD or DVD, great for portability, but really slow and easy to scratch. Then there's magnetic, your classic hard drive. It gives you tons of space for a really low price, but it has moving parts, which makes it a bit fragile. And finally, solid state, or SSDs. These are the champs. Super fast, really durable, no moving parts, but yeah, they do cost more.
And hey, here's some really good news for your revision. The spec is very clear on this. You do not need to learn about the complex guts of these drives. No lasers, no platters, no flash controllers. Phew! Just focus on comparing them using those 6 characteristics we just saw: capacity, speed, portability, durability, reliability, and cost.
Okay, time to switch gears and talk about the numbers. Understanding data units and knowing how to calculate file sizes, these are some of the key math skills you're going to be tested on. This all comes under Spec Point 1.2.3.
It all starts with the smallest piece of data, a single bit, just a 0 or a 1. Group 8 of those together and you get a byte. From there, it's pretty simple. 1,000 bytes is a kilobyte, 1,000 kilobytes is a megabyte, 1,000 megabytes is a gigabyte, and so on. You just have to know that order: bit, byte, kilo, mega, giga, tera. It's absolutely essential.
And speaking of calculations, they'll likely ask you to figure out a file size. An image file is a classic example. And honestly, it's just simple multiplication. You just take the image's width in pixels, multiply it by the height in pixels, and then multiply that result by the color depth, which is measured in bits. That's it. That gives you the total file size.
But hang on, why are we even talking about bits and bytes? Why all the zeros and ones? Well, that brings us to maybe the most important concept in all of computer science, and it's also part of Spec Point 1.2.3. And don't just take my word for it. This quote is straight from the OCR specification. All data needs to be converted into a binary format. Everything, every picture, every song, every single letter you type, it all has to be broken down into a long string of zeros and ones. It's the only language a computer actually understands. So since all that data can create some massive files, we need a way to shrink them down. And that leads us to our last big topic, compression. Let's look at what Spec Point 1.2.5 says you need to know. Compression basically comes in 2 main flavors: lossy and lossless. Lossy compression makes files way smaller by just deleting some of the data permanently. It's great for things like photos or music, where you probably won't even notice the missing bits. Lossless is smarter.
It doesn't delete anything, it just finds clever ways to repackage the data. This means you can get the original file back perfectly. You'd use this for things like text documents or code, where every single character matters.
And here is another amazing revision tip straight from the spec. You absolutely need to know the difference between lossy and lossless, and you need to know their pros and cons. But, and this is the great part, you do not need to learn how the complicated algorithms actually work. So don't waste your time trying to figure out how a zip file gets made. Just stick to the concepts.
Okay, that was a lot to take in. So let's take a breath and boil it all down to the absolute must-know facts for your exam. This is the stuff you really want to lock in.
So here it is, what you must remember. First, primary storage. RAM is volatile, ROM isn't. Simple. Second, secondary storage. Be ready to compare optical, magnetic, and solid-state drives on their characteristics. Third, units. Know that hierarchy from bit all the way up to terabyte. Fourth, calculations. Be ready for a question on calculating file size. And finally, compression. Lossy loses data for smaller files. Lossless keeps everything. Got it?
Okay, I'll leave you with one final thought to tie all this together. Think about your phone. It uses super fast solid-state storage, it has volatile RAM to run your apps, and it uses compression all the time for your photos and videos. So, based on everything we've just talked about, why is that specific combination of technologies the absolute perfect choice for a powerful little device that you carry around in your pocket? Have a think about it. Good luck with the revision.